from Borders of Physics.
Who's the author?
I've been reading one called Cocoa Programming in Mac OS X by Aaron Hilgast.
Okay.
So, yeah, that's a good one.
Yeah, that one's... A lot of people like that one. I'm not as big of a fan. That's why I didn't suggest that one. But that one's it's good.
I like it.
Yeah.
It's not for iPhone. It's more for the regular Cocoa, but it's pretty easy to read.
Yeah, there should be, unless you have an old edition, the newest edition does have a chapter or has a few on iPhone development. If you have the third edition, I think.
Yeah, that's what I have.
So okay, well, just curious, good to know if definitely go grab one of those books. If what I'm doing up here doesn't really make sense, or if you need something to kind of just hold your hand through it a little bit more, some of these books are really good. So, okay, let's see here. Some quick announcements. Assignment 1 is due. If we can jump up to the screen, that would be great. So I need to actually put it up on the website, but in case you get to wherever you need to get, or this gets up before I get to do that, you can read from here. So basically, the first assignment, pretty straightforward. You're going to write a little web browser, which at first seems like, oh, let's write a web browser. Well, turns out Apple did a lot of the work for you. So if you've ever used Safari on the iPhone, basically you're going to be piggybacking off of that. And yeah, you'll be using a UI web view, which will give you all the web browser stuff you need. This assignment isn't meant to be super difficult from a coding perspective. It took me about 10 minutes to write it, and I'm not saying that because I'm some sort of awesome coder or something. I'm just saying because if you know how to connect all the little pieces together, you can do it pretty quickly. So basically, what you're going to end up doing is you're going to have a text field and some buttons to move through the history. So the text field, you'll enter the URL, and it'll take you to some website. You'll enter some other URL, take you to some other website. You should then be able to move backwards and forwards through that history. And again, the classes that you'll be using or building this off of have everything you need. I think in the end it'll probably be less than 100 lines of code. So it's not a lot of code. It's you're going to be an interface builder connecting this thing to that thing. You're going to be using delegates and protocols, and we're going to look at that again today, just to make sure that that's all squared away. Trevor? Yeah.
Are the buttons just going to be buttons we're going to grab from the UI interface builder, or are we actually going to use like the navigation bar and the thing I've seen on apps before?
Very simple. What you've seen me do in class, when I grab a button, you're going to do the same thing, except you're going to grab two of them and put something interesting on them to indicate moving forwards and backwards. And I've given you a few hints here. You see that oftentimes I'll jump into the Xcode documentation. I've mentioned UI web view, UI text field delegate, UI web view delegate. I mention those things here because I want you to jump into the documentation and look and see what it is that these things do, what functionality they provide for you, and you'll see as you read through them, you'll be like, oh, go forward, go back. Okay, maybe that's probably what I need to move forward and backwards. Yes? Yes, I will post this online as soon as I get home tonight, probably after I eat. So, yeah. Okay. Yes?
How are we supposed to turn this in?
I'm glad you asked that. So how are we supposed to turn this in? I don't know. Back in the old days, we used to use hand in. I don't have access to that kind of stuff. And Ken's gone this week, so I haven't had a chance to talk to him about it. My guess is I'll figure it out by Friday, but probably an option will be to just come see me in office hours and either show it to me on your laptop, or if you have something a little heavier, just bring it on email it to me or bring it on a USB stick or something, and we'll run it on my machine, and we'll just make sure that it compiles and runs, and we'll take like 3 minutes max per person, so that'll be like 90 minutes for me. Yes?
Do we work by ourselves or in partners or groups?
In general, as far as this assignment is concerned, and I'll tell you what Ken used to always tell me in all the classes I took with him. I don't mind people working together as long as the code you write is your own. So as far as this project is concerned, it's the same thing. This one, it's very important for you to sit through and kind of struggle and wonder why are things crashing, and you're going to kind of go back and forth through Interface Builder and realize, oh, I forgot to connect this, or I connected this thing to this other thing accidentally. So I don't mind people helping each other out in terms of saying, hey, this is how you should do this connection, or that kind of stuff. So I want everyone to collaborate. Just do the work, your own work at the end of the day. Any more questions? For our late arrivals, we have our first assignment, and I'll post that when I get home tonight. Okay, so assignment 1 is essentially out. There will be discussion on Friday, same as this last Friday. Unfortunately, we're not able to record them. We'll see if we can take care of that in the future, but at this point, we can't. So this Friday, probably what we'll be doing is, depending on what we do in terms of view controller stuff on Friday, we might look a little more at view controller stuff if people want to, but definitely we'll be looking at Xcode and the debugger, and just making sure that everyone kind of knows how to use it. And I'll see if I can show you some little simple tricks that, once you know them, just helps kind of working through the debugger. Yes?
It's going to be like last Friday. We're going to bring stuff to each other, or should we use information on what we should use?
I would say bring in your stuff again. I'm sorry, were you the gentleman that had the iMac last time?
No, I had the Mac Mini.
Okay. Oh, but still just as painful. You have to bring a monitor and stuff. I would say make a friend. The gentleman next to you looks like a nice guy. So does the one to your other side. The young lady in front of you maybe will help you out. I don't know. So, bring your laptops. Other stuff, it's up to you. But it'll just be easier if you can actually click around on stuff. And of course, you don't have to show up. That's the other. You can go do something else and have fun or something. Okay. Any other questions? All right. So today we're going to take a look at delegation again. So we had this discussion of protocols. I think it was last time. Protocols and delegation, and so we'll look at that again because that's very important for pretty much all the apps you're ever going to write. Delegation is a part of it. And we're going to look at Uitextfield, which will be important for your assignment, just to see how it is that we sort of hook into that. Then we're going to look at iPhone application structure. So all along, up till now, we've been instantiating or creating whatever template application, and there's been a lot of hand waving. It's like, oh, don't worry about what this thing is, and don't worry about what that class is. What we're going to do today is actually look at most of the different files in the template there. We're going to see where the application starts and how it sort of hooks in. And where Interface Builder comes in, and this files owner thing that we've seen, and hopefully at the end of it you'll have a better feel for just how things work. And then we're going to revisit memory management briefly, and we're going to talk about auto-release. So this is something that I didn't discuss when I first introduced memory management, but auto-release is very important, so we'll look at that, and then we'll call it a day. Okay, so delegation. So does anyone have a good explanation about delegation that they want to share in terms of what it is, what you think it is? Okay, I guess nobody wants to share. That's cool. Okay, so, delegation. So I think the way I presented it last time was, sort of from the political, some sort of political perspective. You send delegates off on your behalf to do things for you. So as far as Objective-C and COCO and the applications we'll be writing, when it comes to delegation, the idea is that there'll be some sort of object, in this case let's call it the boss object, that has some sort of assistant that helps it out at certain times. So in this case, if we look at this boss object, we see that it has a variable I've declared there, ID delegate. And I've mentioned this a few times now, but ID basically is just a generic type, so it could be anything. So in this case, our delegate happens to point to this assistant object. So the idea is that at some point, while this boss object is doing something, it'll reach a point in execution where something that might be of interest to the assistant happens, or the boss just doesn't know how to do something, and it's gonna, or the boss has to go off to dinner, so he's gonna hand off a ton of work to the assistant to take care of, so that when he returns, he can continue doing whatever it is he needs to do. So the way this will work in this example here, so we have our boss object, and it's doing A, whatever that is. And at some point it's done doing A, and it says, hey, delegate, do some stuff. And that's when the assistant object will take over, do some stuff, return, and then the boss object will continue and say, okay, well, now I'm going to do B. And when it's done doing B, it's going to say, hey, delegate, do some more stuff. And so the assistant object will then do more stuff. So basically, it's just a way of kind of connecting some objects together in a nice way. And this is something that we'll use a lot of in the applications we write. So does that make more sense at all, or was this already clear from last time? Any questions about delegation? Kind of high level? Yes?
Just one example that we'll be using to delegate. So you said like the text field, the Uitextfield field, will that, are you going to bring that example up?
Yes. So that's, Trevor's not a plant, but he just happened to know that next up is this guy. So let's look at an example using UI text field. So same thing we've done a million times now, new project, view-based application, and call it text demo. And as usual, we're going to jump into our view controller class. And let me change the font size real quick. Is that visible in the back? Okay. So here we are in our view controller, and let's set up a UI, an outlet to a UI text field. We'll call it field, and we'll set up a property. Non-atomic retain IB outlet. So we know IB outlet's the way we let Interface Builder sort of know that it can connect to this. And so if we head over to our resources and bring up the text demo view controller, this is where we're going to place our text field. So Command Shift L, bring up the library, or up from tools there. And we want a text field, so we've got a text view and a text field. So let's grab the text field, throw that in there. And now we want to connect. So if we press Control on Files Owner, we see some of the outlets, and we see field is that text field that I set up there. The other thing to do, if we get rid of the library, and if we click on Files Owner, and if we look over at this inspector, and on the second tab here, on connections, if we zoom way in, we'll see sort of those same things we saw when I pressed Control on it. So you can also, just from here, drag over and make that connection. Or, since I didn't make the connection, we can also just go in the other direction from the Files Owner to here. And we can connect it, and we see that we've made a connection to our text field. So very important, if you look up here, you'll always see that this guy, if it's not saved, you'll see that little dot there. One of the problems that people will be running into is not saving their interface builder file or their .h files or their .m files over in Xcode. So just remember, if things aren't appearing where they should be appearing, make sure you've saved some stuff. Okay, so if we head on over and just run this, build and run it, let's see what we see. All right, so there's our text field. So now if we click on it, it brings up this keyboard nicely for us. So, type something in it, return, but nothing's really going on. So what we want to do now is sort of take a look at how we can know that this return button was pressed and actually do something with it. In this case, what we'll do is we'll type something, we'll hit return, we'll just log this to the console and dismiss the keyboard. So to do that, what we're going to want to do is we want to adopt the Uitextfield Delegate protocol. So the way we do that, if you remember, we have some object we're inheriting off of, in this case, and you use these brackets, and I type UI, and somehow Xcode just knows that that's what I'm trying to do, and it's like magic. I don't know. And so if you press tab, it'll go ahead and complete. So we're going to adopt the Uitextfield Delegate. So if you press Command and double click, it'll take you to the .h file where this stuff is set up. So in this case, we see we have our protocol Uitextfield, and then in brackets it has NSObject. So it's saying implement a bunch of methods or adopt the NSObject protocol. So you have this protocol that brings in other protocol stuff. So if we look here, we have this optional listing, which basically means none of the methods, or none of the methods between @protocol and @end are required. So some things we see in here: text field should begin editing, text field did begin, text field should end. We see a number of things. This one's interesting here to me. Text field should return. If you look at the comments that they have there, called when the return key is pressed, return no to ignore. So basically, the text field has a set of methods that when the text field's doing whatever it is doing, it's it's sort of the boss at that time. In response to certain things we do, it then will sort of say, hey, you can go ahead and do something. In this case, we can do a text field should return. And I'm going to copy and paste this real quick. And the other thing you can do is press, instead of pressing Command, which is that open apple, if you press Control, sorry, if you press Option or the Alt key, you'll get this little plus cursor sign. And again, you get some documentation, tells you about the Uitextfield Delegate. If you open it up, you get various bits of information, tasks, managing editing the text field's text. In our case, we're interested in this portion here, editing the text field's text. Text field should return. If we click on that and take a look, we get some useful information. Asks the delegate if the text field should process the pressing of the return button. And we see one of the parameters that we get passed is the text field. So the text field that that should return is going to be passed to us so we can look at it and do things with it. Okay, so we've adopted the protocol, and now by adopting the protocol, we've brought in a bunch of methods that we can implement if we choose to do so, because they're optional. So if we head over to the implementation file and paste this in, we can now say nslog text field equals and we can use the text field if we say dot text, so we get some properties there. We can go ahead and grab the text that we've typed in, and we'll say return yes. So if you look at the documentation, if you return yes, what that should do is end up well, let's see what it should do. I was going to say something I thought it should do, but it's not actually going to do it until we do something else I'm going to show you. But so if the return value is yes, the text field should implement its default behavior for the return button. So who knows what the default behavior is? We'll see shortly. So let's stop the app and run it and build and run. And we type some things and hit return, and if we look over here, we've got nothing. So what happened, right? We've adopted the protocol. So if you remember from this little demo here, this boss object has a variable that's a delegate, and basically the delegate has to point somewhere. And so far I haven't gone and actually told the text field who its delegate is. At least I haven't told it in Interface Builder. We know that our text demo view controller adopts the protocol, but we never actually told the text field that the text demo view controller is our delegate. So if we head back over to Interface Builder and we press Control and click on the text field, we'll see that one of the outlets that it has is a delegate, and that delegate is sad because it's not connected to anything. So we'll just hold and drag it over to Files Owner, and it just did the connection, as we see. So we know that Files Owner, which is our, whatever I call this thing, text demo view controller, adopts the appropriate protocol. So now, hopefully, so we save, head back over, build and run. Hopefully something more interesting happens. So blah, 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 blah. Return. And now we actually get some magic. So we recognized that this return button was pressed, and each time I press it, it just keeps having more fun. Okay, so that's some protocols, some delegates. You're going to need to do exactly this to be able to, you know, for example, I don't know, I might want to type some web address, and, you know, when the user hits return, I should be notified about that, and yeah, you'll probably grab that string, feed it to some sort of web browser thing, and have lots of fun. So what would be nice now, though, is if we could make this keyboard go away. So what happens is the keyboard or the text field has the focus right now, so it needs to give it up and say, okay, I'm resigning the focus. And the way we do that is, I believe we can say text field should so text field resign first responder, and that one, if we actually look to see where that is, so again, pressing command, double click, takes us to UIResponder.h. So it just so happens that the text field inherits off of a few things, one of, you know, or inherits off of this UI responder. And let's see another way to see that real quick. Well, let's see that it does what I'm hoping it does, which should dismiss the keyboard, and then I'll show you one more thing with Interface Builder that may or may not be useful to you in the future. So hello. So now I press return, and the keyboard has gone away. You know, we got our little hello out here, and if I press again, our text seems to have disappeared, so that seems to be some default behavior, which you can definitely control whether the text disappears or not when you reselect. So the fact that we had to do this resign first responder this way tells us that that pressing return is defaulted to doing nothing at the moment. Well, before we did this resign first responder thing. So, okay. So any questions on how the delegate thing worked, the protocol? Pretty straightforward? Okay. It sure is warm in this room. Yes?
To get to the other piece of code, is that control click?
To get to which piece of code?
If you were at your implementation, and then you, control click on the resign first responder?
Okay, so to get to the header file, it's command. So that's the little clover-looking thing, the little flower-looking thing, the Apple key right next to the keyboard. If you press that, double-click, it'll take you to here. If you head back, and now if you're pressing Alt or the Option key, double-click, it'll give you some info here. Yes?
How do you switch back and forth between the header file and the volume file?
Okay, so some folks are seeing that, you know, with fairly minimal work, I'm sort of bouncing back and forth between these files. And basically, it's the sequence is Option, Command, up arrow. So if you just keep pressing, while you hold those and keep pressing up arrow, it's just going to flip back and forth. While you're there, if you use the left arrow or the right arrow, it'll sort of cycle you through the files that you've opened, which you can see here. So this one's nice. I use this one all the time. The Command Option up. If you have some weird keyboard, it might be like the Windows key and Alt. But okay. All right. right, so moving on. All right, well, I don't know why I brought this up, because now we're going to just go back to Xcode. But so let's go ahead and take a look at the structure of an iPhone application in a little more depth in terms of what's created for us when we create, when we make use of one of these templates. So I think I'm just going to use this one, but if you do new project, view-based application, you're going to get pretty much what we have now, minus the additions we've put in, but we'll just leave them. So if we look over on the left-hand side, of our project, the template has basically grouped a bunch of things for us. So one of them is classes. So we have this text demo app delegate, the .h and the .m. We have our view controller, which is where we've been putting most of our code in. So that's the place that we'll be doing this management between views and models, and we'll be looking at what that means in more detail soon. We have this other sources directory. So there's this text demo _ prefix.pch. So that one is, it's a precompiled header file, so it's just Xcode's way of sort of packaging up some things so that compilations are a little faster. So I think if we look in there, well, there's not much in there right now, but UIKit.h has a ton of stuff in it. And so there's that. Main.m, which we'll be looking inside of shortly. Resources, which we've sort of taken a look at already, because usually we end up double-clicking on this to take us into Interface Builder. There's this info plist, text demo info plist, which we'll look inside of shortly. Then we have a bunch of these frameworks, and frameworks are just libraries, sort of bundles of header files and objects. So if we look at UIKit, and inside the headers we see all sorts of stuff: accelerometer, accessibility, alerts, buttons. If we look, we'll even probably find our text view in here somewhere, or our text field. So UIKit, that's basically all the stuff you see on screen that we'll be interacting with. Foundation, just certain foundation type elements. So we haven't really discussed containers and that sort of stuff, but we have arrays, and I guess there's we have a calendar. We've seen string a few times, so that should be in here. We've seen NS object. We're always inheriting off of that. That's over here somewhere. I guess that's too big to look at, but so just various important header files. And then there's another one, core graphics, which just has various graphics related things, which we won't worry so much about. So if we take a look at the main.m, this should look very familiar to like the first time you wrote any sort of program in your ECS 30 class. And ECS 40, you've got sort of the main entry point. So main int argc, char star argv. Next up is this NS autorelease pool. So this basically sets up the memory management system, or the pool of memory that we'll be drawing from. And at some point in the future, we'll look more closely at autorelease pools and how we can use them for our own purposes when there's certain efficiency considerations that are important. The next line this is the super important line. So this is pretty much, this is the main entry point into our application. So we see this UI application main, and we're passing in the parameters that main sent us, and then we have these two nil values. So if command double click and jump over into the implementation, we see we're in this UI application.h file, and basically, the two objects that were nil, we see that there's the first one's an NS string principal class name, and then the next one is an NS string delegate class name. So what happens is if these guys are nil, then the system will look somewhere else for important bits of information. So this is where this text demo info plist file comes in. So as we move on and build more applications, this info plist file will become more important. You'll be able to do things like, set the name of your icon so it's not just this little white thing and it's something else. But the thing that's really important is this line, where it's main nib file base name, main window. So if you remember, main window is one of the files that one of the nib files that we've been ignoring. So, let's not ignore it anymore and take a look inside. And let me close some things. So if we look inside mainwindow.nib, we see we have this files owner, which is this UI application type. We have this first responder, which actually we're still going to ignore. I've never had to mess with this in here. Then we have our text demo app delegate, which is one of the other classes that was generated for us. And we have our text demo view controller. And then we have a window, this UI window. So what happens on startup, again, if these guys are nil, we're going to end up looking in this main window nib file. And inside there, basically we have some of the things we need, which is this: we need a UI application, and we need an app delegate. So if we look at our app delegate and look at its outlets and zoom in, we see that there's a view controller, which is connected to text demo view controller, and then there's window, which is connected to window. So both of those are right here in this document. So if we go over to the code and look at text demo app delegate, again, we'll see our window and our view controller, and they happen to be set up as outlets. So what happens when that UI application main launches, what it will do is it will instantiate a UI application, and it will pass itself in to this main window nib as its file's owner. And from there, it's we have this app delegate. So the application is loaded. Some interesting things are happening. Eventually, the application's done being loaded, and so our text demo app delegate happens to adopt the UI application delegate protocol. So now we know we can look inside of it and see whatever methods we can adopt. In this case, the default template has brought this one in for us, which is application did finish launching. So what it's saying is, okay, application has done whatever it needs to do, and now it's saying, hey, I'm done launching. If you care, go ahead and do something. And what we're doing in this case is we're taking our window, which is has been connected here. Like we have our this outlet has been connected, so the window's here in the main window. And what we're telling it is to add a sub view. And basically, so this is all the visual stuff that's on screen. So whenever we've been in our nib files and we've grabbed a text field or a button, those are views that we've been putting into a view. And yes?
So sub view is anything you put in a view,
So a subview, the easiest way to look at it is in Interface Builder. Let me bring up our text demo view controller. So if we look here, we see that there's a view, and we know that we've placed this text field. So when I say that the text field is a subview of view, it's basically, it's a child. So this is sort of the best way I can describe it.
So there's a mouse on subview?
What's that? Yes, there is. So actually now what happens in the code is the window well, there isn't anything to see here, but the window, UI window, let me see. So if we look at a UI window, we see that, so this is a way of kind of looking at the inheritance hierarchy for some things. So if we look at the window, we see that it's a subclass of UI view, which subclasses these other things. So, so yes, you can have a view and then a subview and a subview and a subview all nested together that way. Okay, so, all right, let me see if I can jump back. Okay, so at this point we're saying, hey, view controller, give us your view. And so again, right now we're inside of the text demo app delegate. So if we look at the text demo app delegate, we know that it has, and that doesn't want to go. We know that it has a view controller and a window. So, okay, but what we're doing is we're saying, hey, view controller dot view. So let's see what that is. So here, we have our view controller right here in this file. And if we look at it, it has some outlets, and it has, including that outlet field that we set up earlier when we were typing our text. So we see that there's a view outlet, but it's not connected to anything. So this is where this is kind of where the next step of, not the magic, but of the process happens, where when you ask the view controller for its view, the first thing it does is it says, well, if my view is nil, then what I'm going to go ahead and do is load myself from some other nib file instead. So, and again, yeah, actually, if you look, while I have the text demo view controller selected, we see that it sort of brings up this text here, and you look, and it says view loaded from text demo view controller. So that's that other file, our other nib, where we actually placed our text field. So the other thing we can do, if for example, that window happened not to be open, when the text demo view controller is selected, we can look over here at the attributes, and we'll see that one of the attributes for this view controller is nib name. And if we just leave our mouse over there, it'll tell us something. So it sets the name of the receiver's nib file. So basically, what's happening now is inside our app delegate, we're asking for the view we're asking the view controller for the view, but the view is nil. But there's code inside there that says, well, the view is nil, but oh, I have this property or this nib name, text demo view controller. So what happens is our class where we've been putting stuff in, our text demo view controller, gets instantiated and gets passed in here as the file's owner. So this is sort of how that kind of, if you were wondering why is this the file's owner, how does that work, this is sort of how it propagates through. So now so now we have our file's owner, and and we have our text demo view controller. We now have our view, which comes from here, and is the place where we've added our text field and that kind of stuff. And that's what ends up getting set here. So that's, I don't know, that's essentially, that's pretty much the process from main launching. You go into this UI application main. If it sees that some things are nil, it looks in the info plist file, grabs the main window nib. From there, it has some things set up that the application needs, which is an application delegate and a window, and then it just kind of cascades on. Trevor.
Would you add, if you wanted multiple screens, would you add another view controller? Would you add another window?
Yeah, so that's a very good question. So on applications on the iPhone have only one window, this UI window that we see here. So what happens is, as you have, the way you have different screens is basically what you'll generally do is you'll have a different view controller for every screen. So again, view controller is the thing that manages our data, our model, and the interaction between the view, the stuff that we see. And we haven't really gotten really deep into that and to see how that really interacts. But basically, in general, every screen that you'll have will be a separate view controller. And it's just a nice way of kind of separating things out. And you can use this technique, like the way that the application starts that we've just gone through, to sort of make things kind of link up to other views, if that's how you needed it to work. Okay, so this thing, you're not going to be messing around with main.m, pretty rare, ever. If you mess with it in this class, I'll be surprised. But I've never had to do anything in here. Doesn't mean you won't, but in general, I just wanted to show you this because oftentimes it is a little mysterious. Well, how is it that Interface Builder is doing whatever it's doing with this other stuff? And so hopefully this gives you a little more grounding in terms of how that works. Okay. So next up, more memory management stuff, and this part will go pretty quick, so we'll be done shortly probably. So quick review, memory management. So remember, you own objects that you create. So objects you create, you'll either have sent a message new alloc copy, or the word new alloc or copy will be some sort of substring in the message that you send. The other objects that you own are the ones, not besides the ones you create, they're the ones that you take ownership of. So if someone hands you an object, so you didn't allocate it by using new alloc or copy, but someone just handed you an object. If you want to make sure that that object sticks around for a while, because it's important to what you're doing, you're going to retain it. So as a quick example, and I took this, so there are a lot of guides in the documentation. So one of them is like the memory management guide. So this, I could have written some code, but I happen to be where they had this code, so I just copy and paste it in. Basically, we have this thingamajig object, and we're allocating it. So we're calling this class method alloc on thingamajig, and then we're sending it the init message to initialize it. So we have our my thingamajig, and now at some point we grab this NS array, which is sprockets. So we say my thingamajig, give me some sprockets. So we have some sprockets, and eventually we're done using the sprocket, but because sprockets, in terms of, so my thingamajig sprockets, it's not new sprockets, it's not copy sprockets, it's not alloc sprockets, it's just sprockets. So we're not responsible for clearing up any of that memory. So we're not doing any sort of releases. But eventually we're done doing whatever it is we're doing, and because we created my thingamajig with alloc, we need to release it. Okay, so that's, we've seen that a few times. But now there's some situations where things get a little different. So here's a class method called thingamajig, and basically what I'm asking is, well, what happens here? So Again, we have ID, this generic type, and we're doing the same thing we did on the previous screen, thingamajig alloc init. Same here. So we're allocating and initializing an object, and then we're returning it. So basically what we're saying is that we want this object to live on outside of this method. So, so this is bad based on our rules, right? Why would this be bad? Well, I don't know, you and I don't know how thingamajig is implemented. We do right now because we're seeing it, but pretend we don't have the code. And all we know is that we can send a thingamajig message. And when I do that, I get a thingamajig back. So based on our rules, it doesn't say new, it doesn't say copy, it doesn't say alloc, so I'm not responsible for freeing this memory that's been allocated. But, so basically what ends up happening here is we have a memory leak. Since I'm not responsible for it, and you just left it like this, we're hosed. But, what if this is actually what we want to do? Well, maybe this is the approach. Same thing, alloc init, and now, before we return it, let's just go ahead and release it. Well, again, that's going to be a problem because as soon as we release it, we know, so thingamajig alloc has a retain count of 1. As soon as we release, the retain count drops to 0. When it drops to 0, the system is going to deallocate it. So now I'm going to return a pointer that's pointing to some place in memory that we no longer own, and if we're lucky, that'll lead to problems early. If we're unlucky, it'll lead to problems later, much farther away from where this happened. So the magic solution to this is to use autorelease. So autorelease is basically a way of delaying the destruction of an object. So you would give your callers a chance to retain that object and hold on to it if they want to. So in this case, we're following the rules, right? I called the thingamajig message, and I have all the expectations in the world that that object will be released because there was no new alloc or copy, and I don't have to take care of it. So that would give me a chance to grab the thingamajig, retain it, and hold on to it. And what would happen is if I don't retain it, then at some point during the event cycle, the thingamajig is going to get a release message sent. So it's basically just, by doing auto release, you're saying, hey, put this, mark this for deletion sometime in the future, and that time in the future, as far as you're concerned, will be well beyond wherever you will have wanted to use it. Yes?
Based off a reference count, or is it
No, it is also using reference counting. So when you do the auto release, it should increment the retain count by 1. So now you have it if you feel like holding on to this object. So this is those situations where you want to take ownership of an object you didn't create. So you would send it a retain, maybe using your property, right? So we have our property, and it happens to have the setter semantic of retain, and so we'd have myObject.property equals thingamajig. So at that point, thingamajig will get a retain put on it, and so its retain count goes up to 2. Eventually, this auto release thing will run its course, and it'll send it a release message, and it'll drop the retain count from 2 to 1. I still have, we still have a reference to it. Retain count is 1, so that's good. At some point, we deallocate our stuff, send the object a release, goes to 0, and the system is happy and leak-free. So that's it. Go off, have fun, write applications, write me a web browser. If you're like at 1,000 lines, you should stop. Actually, if you're at 100 lines, something's going on. So, question?
Why are you gonna use?
Why don't we use auto release everywhere? Okay, so quick. There was a quick question, everyone. Why don't we use auto release everywhere? So, on a device like the iPhone where your memory usage is limited, if you're always saying, hey, release this memory at some point later in time, all the time, on every object you interact with, you're going to run out of memory. So the idea is usually if you allocate memory and you don't need it to stick around, you want to get rid of it as quickly as possible. Give it back to the system because it needs those resources. Yes?
Also, you're not guaranteed when that object is going to be released.
Right. Right. So yeah, that release, it might take forever and ever and ever, and you're out of memory again. Yes?
Don't you declare an NS allocation before you can use autorelease?
So the question, if folks didn't hear, don't you need to declare an NS auto-release pool before you can do stuff like this? Well, if we look at main.m, sort of that pool was created for the application. Now, what you can do is you can actually create your own pool locally. So there are situations where you don't want to like allocate and deallocate, because these, allocating and deallocating memory is an expensive process. And in fact, one of the applications I have, I shelved it because I was having performance issues due to memory allocation things where it was just, I needed to re-architect what I was working on because the memory allocation scheme was inappropriate. So what you can do is you can set up your own auto-release pool, where oftentimes what this will be used is in a loop. So you're in some sort of loop where you need to allocate stuff, and then occasionally what you'll say is you'll say pool release, similar to what's going on here, and then you'll free the memory. So actually, I'm showing you this here. This isn't actually the pool that your auto-release stuff goes into. There's some sort of an event loop that has its own auto-release pool. But as far as this discussion here, it's good enough to know that there is an auto-release pool somewhere for you, and don't worry, it'll take care of things for you. Any other questions? Yes.
Let's see. You were save to is automatic save to someone who just takes that, so we're gonna have to create our own arrays.
I'm sorry, I missed the first part.
Well, part of the assignments, we have to remember the history and stuff.
Right.
And that's automatically set to the inside of the icon of the system somewhere, or there's we have to create our own data structure.
So right there, you're not going to have to create your own data structure. So take a look at the UI web view and the UI web view delegate, and what will happen is the UI web view is just wonderful, and basically every time you visit a URL, it'll just happen to kind of keep track of it, and then there'll be some methods that you can call to say move forward or backward. And actually, I have it running here. I can show you. Where did you go? Oh, mini browser. So don't worry about that go button I put there at the bottom. That was just me messing around with stuff. So this was mine. You can make yours look prettier and fancier and all that kind of stuff. Like I said, I threw it together in like 10 minutes. So it's very important. And let's see if this works. But apple.com. Yeah. So, load it up. I can press back. It's not really doing anything forward. So if you're using the simulator, the Option key or the Alt key will bring up these two virtual fingers. So it'll allow you to zoom in and basically get some multi-touch thing going on. So let's say I'm curious about, iPhone. So I click that. It takes me to iPhone. And now I'm curious about something else that they have for me to select here. How about, I want to go to the store. Now that I've seen it, I'm ready to buy. So it's loading. Should be loading.
Now that you've browsed it, does your back button work?
Yeah, that's what I was hoping it would go. Okay, there it goes. So if I go back, I should be on the iPhone screen. If I go back again, I should be back to Apple. If I go forward, I should be able to. So that's pretty much, that's the functionality you're going to have. Any other questions? All right, well, I will go ahead and put this up on the website. See you Friday.